tour of the history of rockets, so important to space travel and the unit we're about to do on NASA. So here's the basic idea about rockets, right? Is all the other modes of transportation involve pushing against your environment, right? Like your car wheels push against the ground. If you swim, you push against the air. If you walk, you push against the ground. And even jet engines mostly rely on taking air in the front, compressing it, and pushing it out the back. And of course, none of those things are going to work in space. So the fundamental idea of a rocket is its conservation of momentum, which means if you throw something out the back, if you throw it really hard, you'll require a large force. And by Newton's third law, there's a large force back on you. So that's the Newton's third law explanation. Conservation of momentum is, if you create some momentum going backwards, then you have to have some forward momentum to cancel it out and conserve momentum. So what you do in essence is you throw, you don't want to put heavy things on there, right? Like a bunch of bricks. So you put something light and you expel it at high velocities, which basically means combusting it. And so remember, the momentum formula is mass times velocity. So what you lack in mass, you make up in velocity, because you don't want to have a heavy payload. So the first recorded invention of this is basically in the use of warfare, and then eventually became fireworks, and that was the Chinese. So they were looking for a way to propel arrows extremely long distances, and so they basically lit gunpowder, variation of gunpowder, and it would go really far, but it wasn't very easy to control. And to this day, that's still true for solid propellant rockets. Is they're powerful and they're stable and all that kind of stuff, but they lack a little bit of finesse because once you light them, they just kind of go. You can't control the combustion that easily. So like I was saying, solid fuel rockets are still used today. So if you look down here in this picture of the shuttle launching, you can see the two boosters on the side. Those use solid propellant. Most of the main thrusters and most of the missions that we're going to talk about getting us to the moon and stuff, though, they did use liquid fuel, which I'll talk about in 1 second. But these solid propellants were used in the shuttle design. These boosters were basically used early on in takeoff and were discarded pretty quickly before the shuttle even left the atmosphere. Now, the big invention, the big turnaround happened in the 20th century, and that was to use liquid propellant, right? And so when you are burning that much fuel and that quickly, and of course, if you're going into the upper atmosphere and eventually into space, you can't rely on the ambient oxygen for your combustion reaction. So you have to put the oxygen in there in a tank as well. So basically, a liquid rocket, you have your fuel and you have your oxygen, which is probably going to be liquid at this point if you compress and cool it. And then you combine it, and then you can control, right? You have a much more, with these pumps, you can actually control your reaction much more precisely than a solid rocket, and you can get higher efficiencies, and you don't have to have this solid fuel. You can use this liquid fuel. So lots of advantages to the liquid fuel rockets, but technologically was harder to make happen, and really didn't happen until the 20th century. And the way it happened, of course, is warfare, right? Just like the Chinese invented solid rockets for war, this is the Germans invented the liquid rocket technology to launch the V2 rockets during World War II. These were at the time, the longest range rockets in the world, and they could launch them from Germany and get them all the way into Britain. These are the rockets that sort of terrorized the British people during World War II. And I didn't know this until I was doing some research on the V2 rocket. The V comes from the word vengeance, so like they were getting revenge for the carpet bombing of their civilian cities that was happening. The Allied forces were, carpet bombing with traditional bombs and planes the cities in Germany, and so they were trying to get their revenge on the civilian population of in England. The testing of these objects are considered to be the first man-made objects that actually made it all the way into space, right? First long-range guided ballistic missile. Now, the Russians soon got a copy. I don't know if they stole an actual device or they got the plans. I don't know what the story is there, but then they were the next to make these liquid rockets, and they were the R series. So R1 was basically, as close as they could get to the V2, and then they had modifications of the designs, which they numbered. And then R7 is the modern, is the version that they actually used to actually beat the United States early on in the space race, right? This is the actual rocket that shocked the world in 1957 when they launched Sputnik, the first man-made object to be put into orbit. And then the same rocket launched Yuri Gagarin into space and became the first man in space. And so the Russians had an early lead over the United States, also based on the wartime kind of arms race and rocketry, trying to keep up with the Germans. Now, the German scientist who was behind this is a very famous figure in both the German history of the war and in the post-war history. The United States he surrendered to U.S. forces and he became a U.S. citizen, and he was lauded as a hero in the United States, but he was a Nazi, right? But we kind of don't talk about that anymore. So he brought that liquid rocket technology over with him, and so he's a highly valued asset. And he eventually settled in my hometown, Huntsville, Alabama, where they named a civic center after him, all that kind of stuff. I didn't know, no one in Huntsville ever talked about him being a former Nazi. I had to find that out on my own. But he went on to develop the Redstone rocket, which is the rockets that underlaid the whole nuclear arsenal, the guided ballistic missiles for the Cold War. And from there, modified Redstone rockets became the initial rockets for the first Mercury missions. And he also led the development of the Saturn V rocket, which, as you'll see, is the most powerful rocket ever built to date. So here's the scale of them. So you've got the V2 on the far left. That's the first one they used, to deliver bombs during World War II. And then you've got the Mercury rocket, which is significantly bigger. This was launching one man capsule into space, into orbit. This is how the United States got their first astronauts in orbit. Or I guess the Mercury Redstone actually didn't get into orbit. It was just a ballistic trajectory, and you need a slightly bigger rocket to actually get it to orbital velocities. And maybe that's what the Atlas Mercury is about. So still Mercury missions. And then the next series are the Gemini missions. These are two-man capsules that could go into space and maneuver into space. And then this giant leap forward to get to the Saturn series rockets is to get a three-man capsule into space. And then if you want to go all the way to the moon, these initial Saturn rockets wouldn't even get you to the moon. You have to have this beast on the right, which is the Saturn V rocket, which is just an amazing piece of engineering. Still the largest man-made machine in the history of men so far. There are plans to build larger rockets, but right now there is no existing rocket that could take a human being to the moon. So the Mercury ones, right? They were invented to deliver nuclear warheads, and they basically took the bomb off the top and replaced it with a one-man capsule, as you'll see in the series we're going to watch in class called When We Left Earth. Really just amazingly dangerous thing to do. And then the Mercury Atlas, like I said, slightly bigger, stronger, more powerful, can get it up to orbital velocities. This is what took John Glenn up and into orbit. And then the Gemini capsule is larger and heavier, and so it requires more thrust to get that payload up into orbit. And the early Saturn rockets were much more complicated and had many more stages, but the one I really want you to know about is the Saturn V. Saturn V had 3 stages, all of which were designed to separate and be discarded, and it was really only this tiny capsule at the very top that went all the way to the moon. Here is the Saturn V rocket. It has 4 rockets on the bottom, 4 thrust, and so you can see, there's 5 of them. You can only make out 4 in this picture, and you can see, this is Wernher von Braun here, it's taller. Even one of them is taller than the height of a man. These things are enormous. They're like 17-story buildings. You can see how big just a single engine is, and this is the bottom stage with 5 rockets in there, 3 stages in there. And people are always asking, like, well, why'd we stop doing it? Well, look at the cost, This is the thing. This is why the United States could do it and no other country could do it in the 1960s, is because it was just so expensive, right? So this is still, to date, the only rocket that has ever carried human beings out of low Earth orbit, right? Every other mission since then, the shuttle, everything the Russians have done, the Chinese have done, the European Space Agency has done, nothing has matched this accomplishment. So here's every single Saturn V that was ever built and launched, right? There aren't that many. The These were practice runs. These early Apollo missions were practice runs to get to the moon and back, and then you finally started landing men on the moon. And then these are the subsequent missions in the early 70s where they drove like dune buggies around and they did more science and they did more exploration. And then the last one was Apollo 17. And then they used the Saturn V to launch the first space station, Skylab. And then that retired the Saturn V fleet. After Skylab, the International Space Station and other space stations were hoisted in smaller pieces and assembled in space because it's just cheaper and easier to do it than to launch the thing whole from Earth. Okay, that's it.